Nope. Everybody know you can't join these meetings from outside. You sign up for a face-to-face class. I'm not allowed to let you join from outside. Does that understand what I'm saying? You sign up for online, you sign up for some different types of courses, then it's a different story. But I'm not actually allowed to let anybody join. I'm not even supposed to record everything. I'm just doing that because so you guys have it there in case you want it, right? But unfortunately, you're not allowed to actually do that, right? Or I'm not allowed to let you join in that manner. I don't. Add ID. Let us see what we have here. All right. Dorcas. Allow. Lolly. Rachel. Melanie. Christina. Joel. Merciful. Cheval. This is crazy. Tanya. Usually people show up the second day. Anyway, Franklin. I gotta tell you, like, you go back 4 years before COVID, wasn't like this. I don't know if you've seen these statistics recently, but it says that I think something like between 10 and 20% of the students that are now attending high school are chronically absent. Now, when I was a kid, I'm just saying the difference, what happened year to year. Every year they used to change the rules in Broward County. One year it'd be this, next year it'd be that, next year it'd be whatever, right? So one year, I remember, they changed the grades. You need 94 to get an A. Made it impossible, right? That was pretty bad, honestly. Then I remember the next year they got pissed that everybody was absent. So if you missed one absence, you can still get an A. If you miss two absences, maximum score you can get is a B. If you miss three absences, maximum score you can get is a C. If you miss four absences, maximum score you can get is a D. Five absences, you fail. Now, they didn't actually fail you. They would stretch it. 9 absences, though. F, period. Okay, per quarter. So you're allowed to miss 36 days in a year. You know what I mean? Which is kind of a lot when you think about it. 36 days. Like if you miss that many days of work, you get fired. So but the thing that's crazy now is when you discuss chronically absent. 9 absences didn't even consider chronically absent. So it's more than that. So you're talking about the person who's not going to school at all. You know what I mean? And it's just it's not good. All right, Franklin. Oh, you still want to join, huh? Sorry, still can't join. Franklin, Lucas. I don't make these rules, unfortunately. I would let them join, but honestly, also people joining at home don't pay attention. Online classes, it's very hard to follow. You know what I mean? And pay attention while it's going on. I usually, if I say I have 35 kids in the class, I'd say 35 students in the class, I'd say about 6 or 5 are really able to pay attention and participate online. The rest of them, honestly. Matthew, Sankavia, sorry. Jaden, Annalise, Zane, Indira, Miss Gandhi, Kamani, Chloe. What's your name, sir? All right. Okay, so I haven't removed anybody from the class yet, but sometime today or tomorrow, I will be removing students from the class if they have not done effectively connected to my math lab. All right. So as long as you've registered for my math lab, I'm relieving the class. Oh, unfortunately, if student has not attended the course, they will not be, I have to remove them. That's a federal law or whatever. Does everybody know what this stupid thing is and why I have to do this crap? Does everybody know what this is? So never attendance period, this thing. So this school and all state colleges in this state and pretty much all states get federal funding based off of the number of students that are full-time equivalent, they say, that are attending the schools. Okay. So if I say you're here and you're not, they made this law that you have to say if the person's actually attending the class for the first whatever week and a half, 2 weeks, whatever it is. All right. So if I say you're attending, then they say you have 4 or 5 classes, you're full time. You know what I mean? And the state gets funding based off that. And some schools lie about this and get money from the government and get sued. Broward College lost $22 million a few years ago because of some impropriety that was occurring with this stuff. I had a student in my class that stole $450,000 from the school. The FBI came and all this stuff. I'll tell you the story one day. But the point that I'm trying to make is this is not a joke. All right. So I don't have a choice. I have to do this. This is the same way it is for all your classes. Obviously, I'm talking to people who are already here, so it doesn't really matter. But the thing is you will get withdrawn otherwise. Does everyone understand? All right. So does anybody have any questions about anything? No, that's fine. Yeah, sure. All right, so we didn't get through very much here. We talked about just some general things about statistics, and then we talked. Question? Say again? This school's got a lot more than that. A lot more than that. Somebody paying for your classes, even if you ain't, right? You got me? Some people are on student loans. Some people are receiving Pell Grants, right? Some people are receiving tuition assistance. Okay. So my point is that like on the books, that money is still being paid. They have to. Otherwise, my ass ain't coming here. You know what I mean? They ain't turning these lights on. These projectors, computers. I mean, this is brand new. All right. I mean, I'm not saying the school has everything under the sun, but you student wants something. Student life on this damn campus alone has more than $1 million. They don't do shit with it. It's open. All right. They don't do anything with it. Okay. So you want to do something? Go to student life. Start spending the damn money on other students. So all right. Statistics, we briefly talked about this. We talked about what a sample was, right? And then we talked about population, and then a population versus sample, and then how parameters came from the population, sample statistics came from, parameters came from the population and statistics came from the sample. And then I gave you one example of this thing here. Does that make sense? All right. And then we said that the idea of all of this was that you're going to sample something, then calculate something based off that sample, which, so like, I want to know what the average amount of, let's say, money people have in Florida or something, right? So we got to go and ask people, how much money you got? How much money you got? How much money you got? Right? And we start taking an average. Obviously, so I don't know. Like if someone walked up to you and starts asking you how much money you got, are you going to answer them? Probably not, right? So there's probably gonna be a lot of people that actually choose not to answer. Does that make sense? That's sometimes called like under coverage, all right? Or voluntary response. Okay. So voluntary response, you don't really want to do anything by voluntary response because people can say no. Does that make sense? If I was to randomly select a student, let's say in each, like in here, right, to represent what's going on in this class, all right, and we take the average. And let's say I randomly was to pick Jaden, all right? If I randomly select Jaden, and then he chooses not to provide the information that I was asking about, anyone like him has a very strong chance of not being included in my sample now. Does that make sense? Because the chances that I find another person like him, I might not. Does that make sense? You get what I mean? Maybe there are other people like him because he's a lot like other people, but maybe they're not, right? So the problem is if someone was to call you and there was a poll going on and they're asking you, hey, what do you think? And you don't answer that, then not only you are not being represented, but honestly, a bunch of people like you are also probably not going to likely be represented. Does that make sense? So voluntary response has a problem because people can say nothing, right? And then you get no answer. Does that make sense? But wait a second. I picked Jaden. I need his answer. Does that make sense? All right. So that's one type of sampling. All right. Systematic sampling. This just means like, for instance, like I select every nth object or nth data point. All right. So what do I mean by that? So like, for instance, maybe I go through the room and I start picking every other person. Does that make sense? Does that make sense? But let's say she always sits in that corner over there. And when I start picking, there's always like, let's say an odd number of people or an even number of people in the room. So I never get to pick her because I always start over here. Does that make sense? Does that make sense what I'm saying? You get what I mean? What if you got like, for instance, the example that they typically say is you have like dorm rooms, all right? And like you got a dorm room, you got another dorm room, you got another dorm room, you got another dorm room. And let's say the first one was male, the second one was female, the next one was male, the next one was female, the next one was male, the next one was female, right? If I picked every even thing or every other one, that means I'm either picking only males or I'm only picking females. Does that make sense? That would be pretty bad. Does that make sense? But let's say you were running a factory or whatever, and the factory was making, I don't know, Coke cans. You were just filling up the Coca-Cola in each of the cans, right? And then as you're filling up these things, then I select every 31st Coke can that comes out, right? 31st can, 62nd can, whatever, right? And then I look at it and I start seeing, hey, is this a can that has a problem or not? Does that make sense? All right. So systematic sampling is something that people do, but the only thing is there can be issues with it also. Does that make sense? There's a problem. The garbage as usual. Sorry. Sorry, I had the wrong background. All right. So this systematic sampling. Does that make sense? Anyone remember any other types of sampling? You're supposed to look at the assignment. Nobody else remembers a single thing from the assignment. Maybe you should do your assignment. They said something about cluster sampling, stratified sampling, random. We talked about that last time, though. Does anybody know what the difference is between cluster sampling and stratified sampling? This is a little bit confusing. No. Most of them are pretty simple, to be honest, except for these two. Just want to make sure that I've written all the ones that generally people discuss. Yeah. Systematic stratified cluster. Yeah, okay, that's what they said. All right. So systematic, we already said this. Stratified. So for instance, like if I take an entire region and then I break the region up into these little parts here, which we refer to as a partition. Does that make sense? A partition is something where you take the union of all of it and it's going to cover the whole thing. But then each of the individual things don't overlap with each other. Does that make sense? Or they have no intersection. Does that make sense? All right. So this is called partition. So if I partition something, each of these things can also be called strata. Does that make sense? All right. Like states in the United States, right? Does that make sense? Right. You live in, your residence is in Florida, it's not in Georgia. Does that make sense what I'm saying? So then what I would do then is, let's say randomly select 50, let's say, from this one, this one, this one, this one, this one, and this one. Does that make sense? So that would be like an example of stratified sampling. Does that make sense? You take something from each of the groups. Does everybody see that? Cluster sampling. So this one's stratified. Do you guys get what I mean by this? This is easy to make a mistake. Okay, this thing. This is confusing. This one. All right. Cluster sampling. Cluster sampling is like same type of thing. There's some sort of partition. Okay. But now we don't select all of them. Now I randomly select clusters. Does that make sense? I might randomly select within the cluster also, but I don't necessarily get someone from each thing. Does that make sense? Do you understand what I mean by this? Randomly. The key thing always is randomly, because if I don't select randomly, then I'm picking my friends, I'm picking people I like. No, that's no good. Does that make sense? Everything needs an equal chance of representation. Okay. So in this case, each of these things, or every member of each of these individual classes or strata here had an equal chance of representation. Does that make sense? And then here, when we're looking here, each one of these individual clusters had an equal chance of representation. Does that make sense? All right. Now you could say you're going to select everyone in the cluster here also. Okay. Everyone in this cluster, everyone in this cluster, everyone in this cluster, everyone in this cluster. That's not usually practical, but that's what you would want to do. Does that make sense? Question? You get what I mean by the difference between these two things? Like, let's say there's like, the example that they always give, which I think makes a lot of sense down here, is like you go to the airport and then there's a bunch of gas stations nearby. Okay. And then usually the thing that people want to know is, hey, I'm going to leave my car at the parking lot there. Which gas station am I going to go to? Right. Which one's cheaper or whatever. Right. Or what are the prices? Are the prices more near the airport or the prices more elsewhere? Right. So then what we're going to do is, hey, I need to see some sort of random selection of these types of gas stations, right? And compare them. Does that make sense? So then I'm going to take the gas stations nearby, but I'm not going to select all of them. I'm going to randomly select these gas stations. That would be an example of like cluster sampling. Does that make sense? Because like, oh, the gas station's over there, that's the ghetto. Cheap. Oh, the gas station's over there, there's these banks and all this other nonsense. They start charging crazy money closer to the beach or something. You know what I mean? Does that make sense? Question? Do you understand why sampling is important, though? All right, and how if you introduce bias into the sampling, you are corrupting the entire all the results you're getting. Does that make sense? What I'm saying? All right. All right. I think that's pretty much the only thing you have to know about the sampling. All right. Frequency distributions. Does anybody know what a frequency distribution is? You should be able to just read the word, to be honest. There's not a person in here that I believe doesn't know what the word frequency means. Frequency answers the question, how often? So what do they mean by frequency distribution? And what would that have to do with the sample? A way to organize the data? That's correct. So like how the data is organized. Does that make sense what I'm saying? How often each particular data point occurs. Does that make sense? Each type. Oh, black girl. Oh, white male. Oh, this thing. Oh, that one. Green this, whatever, right? You have to pick each group how many of those were occurring. Does that make sense? Is everybody a white male? You get what I mean? Like you have to, so if not everybody is a white male, then we should be appealing to the other groups as well, based off of how often they're likely appearing. Does that make sense what I'm saying? I mean, I want to appeal to everyone, but at the end of the day, if there's a person like me who's a Jew Indian, how many other people are there that are the same culture as whatever the culture I have is? Probably not that many. Does that make sense? So my point is are you going to cater to that specific type of group? It doesn't make any sense to. Does that make sense? Right? But if you start turning around and saying, hey, you have 10% of the population, you would cater to this type of group. Does that make sense? But what size should you stop? What would you say? Well, I was thinking percentage of the overall, but effectively that's like a frequency. We're going to say what that means in a second. It's called relative frequency. But if I said you have you have black people, white people, green people, blue people, whatever, right? A certain percentage of each group. Is that correct? Right? So how small does the group have to be for us to not pay attention to it anymore? I think this is actually an interesting question because the reason why is that we're going to talk about a lot of stuff in here, and we're going to say later on, well, not very soon, actually. I mean, not very far away, excuse me. We're going to say that like statisticians always come up with this thing, and they start saying this thing about 5%. If something occurs less than 5% of the time, a lot of times people will say that if something occurs less than 5% of the time, that it's significant. Does that make sense? Well, depends on what you're talking about. In the cases that we were just discussing previously, you'd probably start saying it's insignificant. The group is not large enough for us to actually discuss its representation. Okay. But if I start saying that you say that everybody on average is going to bring, let's say, $5 to class. Okay. And then I check and I sample everyone. All right. And we determine that people start bringing $20 or more to class. Okay. That's far away from the value that you're suggesting. Does that make sense? So then the thing is what's the chances that if you were right and people brought on average a small amount of money, right? What's the chances that people actually ended up bringing a large amount of money if you're correct? I mean, it's random, right? You don't know who walks in here. Might be Gucci Man, right? Well, you know what Gucci Man is? So but I'm joking, but you don't know who's gonna walk in here, you know, Bill Gates, whatever, right? That person walks in here, all of a sudden the average amount of money in this room is way higher than any other room anywhere. Does that make sense? Right? So you don't know who's gonna walk in here. Is that correct? But so it's possible we get people in here that just have billions of dollars, right? Everybody. Okay. It's extremely unlikely though. I would assume that really people would usually bring less money, right? So if we assume people bring, let's say, $5, but then people end up bringing $20, what's the chances, given the fact that people usually bring around $5, that 30 people brought 20? Should be a very small chance. Does that make sense? That's what I mean by significant. Does that make sense? All right. So anyway, the point I'm trying to make is that there's going to be some like imaginary dividing line that people are just going to make up, right? Where they're going to sit there and start saying, all of a sudden, hey, these numbers aren't that important anymore. Or all of a sudden, these numbers are important. Does that make sense? Typically, that is around 5%. Does that make sense what I'm saying? All right. With regard to this population thing that we were discussing, it's kind of the other way around. But still, you could use 5%. Now maybe you say, hey, 5% is no good. I think if they're less than 1%, then we should stop paying attention to them. Does that make sense? You might be right. This changes based off the situation. 5% is like a general rule of thumb. As a matter of fact, people make fun of statisticians about this because where the hell does 5% come from? Why are they using 5%? Why not 6%? Why not 2%? Why not whatever, right? But my point is maybe if you're dealing with some sort of medical application, you want to be much more sure, right? Maybe if you're dealing with this type of estimation process of what we're doing, we don't have to be as sure. Does that make sense? All right. Do you get what I mean? I mean, if I sit there and I start saying less than 5%, there's only 100 people that are going to show up. We're saying that there's going to be less than 4. I mean, it's 4 or less people, right? Right? 5% of 100. Is that correct? Yeah. What are we going to do? We're going to sit here and plan all this stuff for 4 people? I mean, maybe, but probably not. Does that make sense? All right. Frequency distribution. Explains, well, let's just say frequency first, I guess. Frequency answers the question, how often? Is that correct? All right, generally, so we're going to get our data. We get our data. So let's say I was collecting hair color, okay? So we get like brown, blonde, brown, etc., black, whatever. Does that make sense? Getting a list of these values is absolutely useless. The next thing you should do is try to organize them somehow, right? So what they suggest to do is organize them in a frequency distribution. I'm going to write it this way over and over and over and over again, okay? Where xi are the individual values that we're collecting, and then fi are the respective frequencies associated with those values. So let's say we have value 1, value 2, value 3, value 4, whatever these values are, and then there would be an associated frequency with each of these values. Does that make sense what I'm saying? Like brown hair is the first one, the number of brown hairs. Blonde hair is the second one, number of blonde hair people, whatever. Does that make sense? Question? All right, so frequent. Do you get why I would want to do this? Like otherwise, you would just have a list of data. I don't know what that means to anyone. Does that make sense? Oh, blonde, brown, red, blue, blonde, brown, black, brown, blonde. It's like, what the hell is that? Does that make sense? Okay. So the first thing we want to do is usually organize the data in some sort of table format. We usually refer to this as a frequency distribution. Okay. Now, if you had like a frequency distribution associated with, let's say, the scores at one school and the frequency distribution is scores at another school, you can start comparing, maybe, right? Seeing which school was better, which school was worse, etc. Does that make sense? Sports teams, right? This is done all the time when you think about it in sports. That's how I started learning all this stupid crap, actually, because when I was a kid, I liked sports, right? And then next thing you know, they gave all these statistics. And I was like, wait a second, how good is Magic Johnson? I want to know, right? And then it started saying all this stuff. And I was like, oh, like I don't like math in school, but this is better. I learned a lot from it, actually. All right. And then I remember when I was in high school, I did a statistics project and I started trying to predict how well the team would win based off of like the different, statistics that the team has. Does that make sense? It worked really well, actually. I was surprised. It works like 99.8% of the time and stuff like that. You could say who's going to win the game. But but that's actually what all these people use to determine how do people bet. All right. Here's another good one. I remember when I was in college, I sat there and did all this stuff with probability or whatever, and then these kids started gambling online. And I'll tell you a story about this, but I went to a casino and we ended up gambling, like I think it was $26,000 or whatever, and then we ended up making like 40-something thousand dollars. I almost dropped out of school. Anyway, it's a good story. I'll tell you later. So but my point is like if you tell me you're not going to use this crap, it's on you. All right. I don't know why. Why would you not use this stuff? All right. I can give you so many examples where you're going to use these things, or excuse me, this is the way to decide how to make a decision or something like that. You don't learn it. You're just going to make a decision willy-nilly. You're going to be asking somebody else. And then you're putting all your faith in that person. Does that make sense? And that's never a good idea. I don't care if it's your parent. I don't care how smart they are. It doesn't matter. Does that make sense? You always got to look at it. All right. So frequency distribution, frequency, how often, right? All right. This is kind of good, but it's kind of bad. So like if I say to you, you made $1 million last year, is that good? You think so? What if I say you borrowed $1 billion? Yo, you borrowed $1 billion, you made $1 million. You got $1 million. Of course, you owe my ass $1 billion though, right? No good anymore. Does that make sense? Right? What if I say you made $1 million last year, but 2 years ago you made $1 billion? Yo, your ass is broke now. What's gonna happen next year? You're gonna lose money, right? Probably. Does that make sense? You made $1 billion and now you're only making $1 million? Billions 1,000 times as much. Is that correct? All right. My point is that relative comparisons are important. Saying a number and stating its magnitude doesn't really tell me that much. Does that make sense what I'm saying? So like there's this thing that they start talking about, they start saying relative frequency. If you can spell relative frequency. Relative frequency, does anybody know what that equals to? You should know what this is. You should have seen this in other places also. Anybody remember? Like every science class I've ever taken, this is why they start the class. They're like, oh, what's the error? Oh, what's the relative error? And they start saying these things. They make you calculate this garbage. Nobody? All right. Relative frequency is going to be the frequency divided by sample size. All right. And then usually people make this a percentage. So sometimes people will say this here times 100%. I think that if you need that times 100% thing, you already got a problem. All right. Because you have to be able to convert between decimals, fractions, and percentages. Does that make sense? You have a calculator. Every calculator does it. Okay. But you should know how to do this anyway. Does everybody understand what I'm saying? Question? Percent. All right. But I'm gonna explain that slightly differently. Okay. I don't use this thing. And I think if you use this, it's gonna be a problem. All right. So, but this is what every book says. So I'm gonna write it. Okay. But then I'm gonna explain why I think it's really stupid. Okay. So relative frequency means this. So this is just some sort of percentage or fraction. Is that correct? Right? If there's 4 blonde people and there's 20 people, 4 divided by 20, right, is 1/5. It's 20%. Does that make sense? But you already know this, okay? Because I know you know how to convert between decimals and percentages. Is that correct? How do you do that? How do you change a decimal to a percentage or a percentage to a decimal? That's correct. You move the decimal place 2 places. Is that correct? You don't know that? You didn't think about it. Percent. What does cent mean? Hundo. Is that right? When I say per, what does that mean? Usually like divide though. Does that make sense? All right. Dollars per hour. Total dollars divided by total hours. Does that make sense? Does that make sense? Per means divide. Is that correct? So if I start saying relative frequency here, frequency versus sample size, great. If I start saying there's 4 blonde people and then there's 20 total students, first of all, you should be able to tell me you know how to simplify a fraction. Your calculator will do it anyway, but you should be able to tell me you can figure out a common factor. Is that correct? Great. So you get like 2 and 10. Divide by 2. Is that correct? Divide by 2 again. We get 1 and 5. Is that right? Just keep dividing by something. Eventually, you can't do it anymore. Is that right? All right. So then this is 1 out of 5, right? Great. I think you should be able to simplify fractions. Again, your calculator can do it for you, though. Okay? You should be able to convert this to a decimal. How do you convert this to a decimal? This is the part I have a problem with when you don't tell me you don't know how to do this. There's not a damn person in here should be able to tell me you don't know how to do this. Yeah, what the hell else am I going to do? Stupid thing says 1 divided by 5 here. I don't, what else am I going to do? Is that correct? So why don't you just do that on the calculator? It'll give you the decimal. Is that right? Great. I'm just gonna write it out just because I'm a jerk. But 5, 1, right? How many times does 5 go into 1? Oh, it doesn't, right? So then I need to borrow something. So I grab something over here. Is that correct? 5 goes into this 2 times. 2 times 5 is 10. We get 0. Is that correct? This must equal to 0.2. Does that make sense? All right. But decimals suck. Fractions are good. Fractions, you can cancel things. Decimals, you can't. Decimals are bad. You think decimals are good? You'll make tons of mistakes just typing them in the calculator. Does that make sense? All right. So in this case here, what you could say also is 4 out of 20 is equal to what out of 100? How do I figure this out? No. I don't know why they teach this bullshit. I'm serious. I have no idea why they teach this garbage. Okay. I'll explain why in a second. All right. I hate it when people say this stuff because this is the way these algebra teachers in middle school and high school start teaching this crap. And they're not teaching you the right way at all. Okay. So, like, if I have this here, right? The only thing that you ever need to know about solving an equation is isolate the variable. Is that correct? Get stupid x by itself. Is that right? So, how do you do that? You undo what was done to the x. Is that correct? What did they do to the x here? They divided by 100 is correct. So all I have to do is multiply by 100. If I cross multiply, I have to do 2 operations. Why am I going to do with 2 operations when I only really need to do 1? Does that make sense? So there are certain cases where cross multiplying helps, but in reality, all these teachers are doing by teaching you how to cross multiply is try and say, I'm not going to teach you how to do fractions. You don't know how to do fractions. Let's get rid of the fractions. Let's make bigger numbers, and you will cause more problems to you by making the numbers bigger. But there won't be any fractions, so I won't have to teach you. Does that make sense? So instead, what you do is you're just like, oh, multiply by a hundo, multiply by a hundo. Now again, what's the point of fractions? Canceling. Does that make sense? So you're just like, yo, cancel, cancel. Does that make sense? Then this thing, oh, 0 cancels with that. I could take a 10 out. Is that correct? Then 2 cancels with this. We get Cinco de Mayo. Is that right? Then 5 by 4 is 20, and we get 20. Great. In other words, 4 out of 20 is the same thing as 20 out of 100. Yeah, well, no shit, actually. 0.2 is 20 out of 100. Is that correct? But I'm just saying the fractions make much more sense. All right? If you think they don't, it's just in your head. Does that make sense? But it's because of some stupid teacher, not because of you. That might be me also, but all right. So the thing is this is pretty important. Okay. Now, what would I expect you to do? I mean, so you do 1 divided by 5. I would just do it on my calculator. It gives you 0.2. Is that correct? Once you have 0.2, someone starts saying, hey, we want to convert this to a percentage. All we do is move the decimal 2 places over. Is that right? So then we would get 20%. Is that correct? So my point is there's no way someone can tell me they don't know how to do that. Does that make sense? You have the calculator. I know you can click divide. I know you can move the decimals 2 places over. Does that make sense? Right? The worst thing that's going to happen is I forget. That's all. Does that make sense? But if you do it enough times, you won't forget. So the formula says to multiply by 100%. So the reason why I find this to be stupid is because if I start saying it's 4 out of 20, right? Then this already is equal to 0.2. Is that correct? I already know that 0.2 means 20%. Does everybody see what I'm saying? So this is kind of dumb. You don't need it. Does that make sense? You should be able to convert between fractions, decimals, and percentages. Does that make sense? All right. Another thing that we have to know how to do before we get back to relative frequency is if I start saying like 20% of X, this means 20% This means 20% of means times. Okay? 5 sets of 4, right? Does that make sense? Then all you do is change this back to a decimal. Does that make sense? Move it 2 places the other direction. Is that right? Decimal moves 2 places that way now. Does that make sense? Because percentages are bigger because you divided by 100. Does that make sense? Right? So then if you go the other way, you multiply by 100, but then it moves it other thing moves over. Question? All right. So in other words, if I said to you, what's 20% of, I don't know, 156, right? All you do is 0.2 times 156. Does that make sense? So what is that? 32.2 or something? Is that right? I don't know. Does that make sense? Question? All right, so this is the following frequency distribution. Analyze the scores on a math test. Find the class boundaries of the score interval 40 to 59. Class boundaries is some like number at the beginning and some number at the end of each class that would separate the things out. All right. So then what they say is make this one at the beginning 39.5 and this one right here 59.5. Why would I do that? Because if I said take all the numbers between 39.5 and 59.5, all of those would fall in the first class. Does that make sense? How do you determine these class boundaries? So the ones in the all you do is really just take the average of these two, like this number and that number, and then it'll give me this. Does that make sense? All right, let's just recall also. I should have said this, I apologize. How do you find the distance between two numbers? So what's the distance between 17 and -7? Sorry? 24. So like if you have 17 over here and -7 over there, zero's like over here somewhere, right? And there's like 17 units on this side, there's 7 units on that side, so it's definitely 24. Is that right? But the way we do this is we start doing 17 minus -7. Does that make sense? Right? So if you have two numbers, whatever they are, A and B, A is larger than B, the distance is A minus B. Does that make sense? This seems stupid and obvious, but honestly, it helps. Okay. What if I say the midpoint between two numbers? How do you do that? So if this is A and that's B, how would I find the midpoint between them? Or let's say this was -7 and that's 17. How do I find the midpoint between these two numbers? Divide what? What do you mean? Divide. Use the divide. Then what? You can't just divide that by 2. I mean, if you sit there and you start telling me that you have 1,000 here and then like 1,010 there, the distance between these two numbers is 10. The midpoint's not 10. The midpoint's not 5. Does that make sense? Midpoint can only be two numbers. All right, that's correct. All right, but we need to make sure we understand this. Does everybody understand what I'm saying? All right, if you find the distance between these two numbers, which would be 10, right? Then I half that distance. Then I add 5. That's definitely the midpoint. Does that make sense? Does that make sense? You took half the distance, you added it. Is that correct? All right. All right. I don't like doing this, but I'm going to write out a formula right now just to make sure you believe me that this is correct. Does everybody understand? All right. Then we're going to use it, and it's going to be very obvious, and you're going to tell me I should have known it the whole time. Does that make sense? All right. So, but I have to do algebra. Okay. All right. So, if I have, let's pretend, let's just make B larger than A. Okay. If I have this, right, then obviously the distance between here and here is going to be B minus A. Is that correct? Therefore, then half of the distance. See, this is why I like fractions. You just like, oh, B minus A divided by 2. It's half. Does that make sense? So then this part is B minus A over 2, B minus A over 2, whatever the hell that means. Is that correct? Now, we start off at this position, and we need to move to there to get to the midpoint. So I'm going to call this M. All right? M is going to equal to A plus half the distance, which means A plus B minus A over 2. Is that correct? Does that make sense? How do you add fractions? You just got to make sure the bottoms are the same. Is that correct? Right? So then this thing needs a 2, right? You can't just divide something by 2. You're changing the entire number. Is that right? But if I divide by 2 and multiply by 2 at the same time, I'm changing nothing. Does that make sense? Does that make sense? Then that means this is going to equal to 2A plus B minus A over 2. These two can be combined, right? They're like terms. So then we get A plus B over 2. So then that means that the midpoint of A and B, no matter what the two numbers are, is A plus B over 2. Why am I saying that makes sense? What's another name of this? That's the average. That's the average of A and B. Is that correct? How do you find the average of two numbers? You add them up, divide by 2. Is that correct? The average is what we say sometimes. Question? The average, what we say sometimes, is the center of mass. Does that make sense? So, like, if I have 3 places here, and I was to say, like, where is their average? Let's say it's like right there. If I had like a triangle, and then I put my finger, like if it was like a piece of paper or something, and I put my finger directly underneath it right there. If I was able to do that, it would balance. Does that make sense? Because like the stuff on one side is the same amount as the stuff on the other side. It's the average. Does that make sense what I'm saying? Does that make sense? All right. Questions so far? All right. We still have to go back to relative frequency, I said. So then this thing here, to determine what the next boundary is going to be, what they say is so these things I call right here lower class limits. These are called upper class limits. Sometimes these things are not called classes. Sometimes they're called bins. Does that make sense? There's more names, but something like that. So then this 75 and 76, right? We say that the class boundary between those two things is 75 plus 76 divided by 2, or 75.5. Does that make sense? So any number between 75.5 and 59.5 would fall in class 2. Does that make sense? Does that make sense? So those are what class boundaries are. Any question with that? So what are all the class boundaries? So this one was what, 39.5? What's the rest of them? 59.5? What's the 75.5? What's after that? 82.5. What else? And then what's the last one? 99.5. Any question? Okay. The following frequency distribution analyzes scores on a math test. Find the class midpoint of the scores in the interval 40 to 59. Why would we want to do this? Like whenever I take these classes and stuff like that, like I would constantly ask these teachers, like, why am I doing this? And they'd be like, oh, just because you are or whatever. And I'm like, no, there's always some reason. And once you know the reason, it's not as stupid. Okay. So again, people would try and shut me up all the time. But I would sit there in the class and I would just be like, you can already tell I'm pretty obnoxious, right? So I would just, what are you laughing about? Why you agree so fast? Anyway, so like the no, but you know, I would sit in the class, these teachers wouldn't ask this thing or they wouldn't answer the question, right? Yo, I paid for this. You're gonna answer actually, because I'm just gonna keep asking. And then I'm gonna get the other kids to start asking because they're gonna be like, wait, what the hell is he talking about? Right? So one way or another, you're gonna answer the question. Does that make sense? Don't let these people get away with this crap. All right, so the following frequency distribution analyzes scores on math test. Find the class midpoint. Now again, why, given this class right here, would we want to determine something about the midpoint? When you look at this chart, what's the first question you start, or what's the questions you start asking yourself about it? Like what causes confusion here? There's something that's annoying with this, the way the information is presented. How they group the scores is kind of weird. That's true. Because it's like these things are not all like the same like gap between them. Does that make sense? Okay, so that's true. But what else? There's something else that's kind of annoying. What do these two people get? Somewhere between 40 and 59, right? Does that make sense? Like, I mean, don't get me wrong, we have to put information like this and you have to start grouping in some manner, but I don't know what score they got, right? Now, what if we needed a number? What if we wanted to say, let's calculate their average or something? Does that make sense? Which we're going to do in like 2 seconds. All right. So you have to know how to do this. You have to know how to find the median of this. Does everybody understand what I'm saying? Will you be able to do it on the calculator? Yes. But if you don't know what it means, you're not going to be able to answer the questions anyway. You're not going to know which thing to do. Does that make sense? I want to know about these two people, though. I want to know what scores they got, right? They got the worst scores in the class. I need to know. I'm the teacher, right? Right? Why would I take the first of all, what would the average, what would the midpoint be? And then why would I do this? Tell me what the midpoint is, please. That's correct. So so like right here, you did 40 plus 59er divided by 2, right? Now the only thing I was saying is I was just thinking like 40 to 60, the midpoint's definitely 50. Is that correct? All they did was subtract one number, so I subtract half. Is that right? But you know, I don't like trusting myself with these things. There's a formula. I just plug in the numbers. We get 99 over 2. We get 49.5. Is that correct? Great. Why the hell am I calculating this? Who cares? What is this for? Again, what am I asking about initially, and how is this answering my question? I was asking about those two people, right? So, yeah. We were asking to see their score. We need to estimate their scores, correct? Okay. Why is this a decent estimate? That's not an answer. Why are you a good boy? Because I'm a good boy. No. You know what I'm saying? All right. Why is the midpoint a good answer? Because it's the midpoint. No. Does that make sense what I'm saying? All right. So like go ahead. Yeah, but that midpoint average means the same thing in this case. So that's not adding information. That's not explaining it. Does that make sense? Go ahead. It has the least distance from both sides. Okay. But why would that matter though? Well, we don't really know where these people got. They're somewhere between 40 and 59, right? But if I pick something too close to 40, then I'm saying these people are flunking more for no reason, right? If I pick something too close to 59, then I'm saying that they could have gotten higher scores for some reason. Does that make sense? We need to be as fair as possible to try to pick the best estimate that would possibly represent the overall situation as well as we can. Does that make sense? So to not bias towards larger values or higher value or smaller values, excuse me, right? This should be the best choice without any more information. Is that correct? Does that make sense? All right, but that gives you a reason to think why we start calculating the average for a lot of stuff, right? Does that make sense? All right, what are they doing? So midpoint for 4059 was 59, 49.5. Why don't you do 76 to 82 real quick just to make sure? You know, this way I'd probably do it the first way I was talking about because the numbers aren't that far apart. But don't make any difference. You got a calculator, you do it however you want, as long as you get the right answer. What'd you say? 79 is correct. So like the thing is though, what I was thinking, because I like to like, okay, this is also like really important. All right. We have to do a lot of things on our calculator in this class. All right. But you type the wrong thing in the calculator, it's going to spit out nonsense, right? Obviously, right? You need to be able to tell when that's happening. Although you can't just always just trust the result of the calculator and just assume that it's the correct answer. Does that make sense? You need to look at it a little bit and you need to start seeing, hey, does this make any sense in this situation? Could I possibly have typed a 12 when I meant to type a 19? You know, whatever. Does that make sense? All right. When I do statistics and I have to do stuff, you know, for some people or whatever, a company or whatever, they start giving me all this data. I spend 85% of the time writing programs and doing things just to make the data look right and nice so that I can do something with it. You got to organize it first. Does that make sense? All right. But if this thing right here, if this distance is 6, half that distance is 3. 3 plus this is 79. Is that right? Does that make sense? Don't get me wrong. You could do 76 plus 82 all divided by 2, but you need to know what it means. Does that make sense? Question? Anybody have any question? All right. Determine the class width, they say now. Okay. Class width is the distance between any consecutive lower class limits or the distance between any consecutive upper class limits. This is going to be really easy in a second, right? Also, it's also equal to the maximum value rounded. We'll explain what this means in a second. Minus the minimum value divided by the number of classes. All right, so because what we're gonna have to do, so in a second they're gonna give us a bunch of data and they're gonna start saying, hey, make a frequency distribution based off this. Does that make sense? And then they're gonna say make a histogram, which is just a bar graph. All right. So we're gonna have to actually be able to figure out what the class width is first when we usually have the data. But first, let's explain what it is if we had an example. All right, so let's say they provided some frequency distribution based off these lower class limits and upper class limits. You ever see that? What's the class width in this case? Read what I wrote, then do it. Midpoint was middle, right? Class width, does that sound like middle to you? It's like how wide something is. Is that right? 89 it should be. That's not even close to a 9 though. 10 is correct. How'd you get 10? So it says between any consecutive lower class limits. So from here to here is 10, 10, 10, 10. They 10 wide. Is that correct? How about from here to here? 10, 10, 10, 10. And it has to be the same for all of them. Otherwise, we can't say there's a class width. Does that make sense? Or like we'd have to do the class width for each individual one separately. Does that make sense? Question? You get what I mean by this? Does it make sense, guys? Why is 10 like a reasonable thing to say? So if you start picking the numbers from 60 to 69, right? There's 10 integers in there. If I go from 0 to 9, we have 0, 1, 2, 3, all the way up until 9. That's 10 things. Is that correct? Does that make sense? So the width of 10 in this case actually makes sense. You understand what I'm saying? You get what I mean? Even though you got a Dolphins hat. Jets, Jets. Sorry, they won a game. Like that doesn't happen every year. So like that's probably the last one too. Man, I was dying though at the beginning of that game. Like 4 plays in, Aaron Rodgers gets injured. He's out for his career. Boy's done. He's 39 years old. He's just tore his Achilles. It's over. That was Kobe Bryant. He's done. So then the this thing, distance between any consecutive lower class limits, distance between any consecutive upper class limits. We'll look at this one in a second. I'll use this other version in a second when we actually have to construct the frequency distribution. Okay. Question? They always make this joke about Jets fans that the best part of the Jets fan season is before the season starts, because once the season starts, it's over. All right, so but you Dolphins ain't far behind. So yeah, we'll see. You guys always screw up. It's good for me. All right, so construct the cumulative frequency distribution that corresponds to the given frequency distribution. What does cumulative mean? Sorry? Combined. That's true. But like up until a point. Does that make sense? Cumulatively, up until today, your GPA is such and such, right? I can't say like what your GPA would be for your grades next semester or something like that. So up until now. Does that make sense? So what we say is like the cumulative frequency is up until a specific point. Does that make sense? So up until everything less than or equal to 71.9, there's 18 numbers. Does that make sense? Actually, I shouldn't connect this. Sorry. So if I say the height is less than or equal to 71.9, if I say the height is somewhere less than or equal to 74.9, the height is less than 77.9, 80.9, and 83.9. These are referred to as cumulative frequencies, or the variable less than a specific value. Does that make sense? So how many should I put in the first one? 18. How many put in the next one? How do you get 40? 18 plus 22. So now I need to accumulate up till here. So that means all these people. So it's 40, right? You just do 18 plus 20 duper. Then what's the next one? 60, add 20. Does that make sense? Then what? Then you add this one. So then we get 76. Does everybody see what I'm doing here? Then the last one, 80. And this would have to be the total sample size. Otherwise, you messed up. Is that right? Question? This is less than or equal to 71.9. How many numbers here are less than 71.9? Are they? These look less than 79.9. There's 18 numbers that are less than 71. There's 18 heights that are less than 70, less than or equal to 71.9. Right? How many are less than or equal to 74.9? What? You got to be able to read this table. Which are the things in there where it says that they're less than or equal to 74.9? Which classes? Like there's a class 1, 2, 3, 4, 5. Right? Definitely. Definitely. Right? These people have heights somewhere between 72 and 74.9, right? That's less than or equal to 74.9. Is that correct? So how many people total have a height less than or equal to 74.9? I don't know what you mean by that. Where are you getting 5.9? Are you subtracting like this and this? Why? No. You gotta think. You gotta think. If wait, no. Actually, like you gotta think about what you're actually doing. Okay. So I'm asking you how many people, right? And you're taking two heights and subtracting. How are two heights when I subtract them going to be telling me how many of the people though? Which part of the table starts telling me about how many people? All right. No, but the point that I'm trying to make is that you will get confused with these things and you will forget what frequency means and which one's the value, right? That's the reason why I was writing it previously like this, where I say like X and F, okay? Because I just need to know which one is which. Does that make sense? And they're always going to be like this. Does that make sense? All right. But, and I'm sorry, like, if it's coming off like I'm picking on you or something like that, but I guarantee a lot of other people are going to make this exact same mistake. And I'm trying to identify to people what's actually going on. Because right now, you might not make the mistake right now. We're going over it. All right. Give you a couple days. Everybody will. All right. It gets confusing. You forget what the stupid shit means. That's just the way it works. Right. And you got to think about it again. But then I ask myself these stupid questions, and I used to get the thing right on the test, and I didn't remember shit from before. And the person next to me studied, and they wouldn't get it right. I don't see the, you don't need to, you got to think what it means. Then you'll be able to answer the question. Don't try and memorize. Does that make sense? All right. Because you're never going to remember all of these things. Well, you got to take a test sometime, right? Final, whatever, right? You're never going to remember everything. It's not going to happen. Does that make sense? But if you can figure it out, you're fine, right? Even if you do really, really, really study and somehow memorize everything right now, you're not going to remember it next semester or 2 semesters from then or 5 years, whatever. Does that make sense? The point is if you know how it works and you understand why it is, the next time when you approach it again, that's the only thing your brain is going to be able to go back to. Does that make sense? All right. No, I'm just saying like it's confusing, but the thing is when it starts saying, so there's going to be a million of these questions and people are I'm going to say, what's the average? And people are going to start telling me, oh, you take the average of this. That doesn't make any sense. If I said, what's the average of the people in this thing? It would have to be something about a height. Does that make sense? So you always got to think like, is it the value or is it the frequency that they're talking about? Does that make sense? And it does get confusing, okay? Question, anybody? No, this is important. Like, everybody should be asking questions. Scores on a recent statistics test are given a frequency. If you don't ask questions, then you're just not getting what you're supposed to be getting. Like, you're paying for it, make someone work for you. Why? You want to do it at home? I don't want to do it at home. You know what I mean? All right, so the scores on a recent statistics test are given a frequency distribution below. Construct the corresponding relative frequency, round relative frequencies to the nearest 100% if necessary. All right. I'm just gonna do this on Google Sheets real quick so that we can remind people how to use this. Actually, you know what? I'm not. You guys are supposed to use this calculator. Let's do everything on the calculator. Because the calculator is actually pretty good. Which one is the damn calculator? I don't remember. Is it even here? No, I put something online that like you can use the calculator on your computer. I mean, this is whatever. So like anyway, the this thing here, this calculator, I'm just gonna do things on the calculator here because I want you to be first of all, you can always refer back to it later. And then the second thing is that you should be doing it along, and then when you do it along, you'll be surprised you get used to it very quickly. All right. Sorry, I just gotta get this stupid keypad here so you can see what I'm typing. Yeah, no. I never remember how to do this. Settings. Uh, yeah, man. Fun. Oh, nice and tiny, eh? All right, this window should, believe it or not, I have an emulator program for this calculator that I have actually, that I have a full license for and stuff like that. I own the calculator also. I have like 20 of these things, but the ripped off version is better. So this key for it should put the keys over here that I touch. Does everybody understand what I'm saying? All right. Okay. We don't use very much of this calculator. Okay. We are going to use this button here, stat. Imagine that. Statistics. We're going to use the stat button. So then the dister. What do you think dister stands for? Distribution. Vars, I guess we do that, but I never really use it. Math we use, but I never really use that either. So really it's just stat and dister. Does that make sense? I'm going to go over this stuff with math, but you don't really need it. All right. So first thing, the whole point of anything with statistics is you don't want to calculate all this crap. So it starts getting really annoying when there's lots and lots and lots of numbers. So you need to understand what the calculation means. And then you start typing the data into one of these computers. It calculates it for you. And then you have to interpret the results. Does that make sense? Does that make sense? You okay? Question? So then the like same thing when you use Excel, whatever. Does that make sense? All right, so I'm gonna click stat here. Yay, it worked. Is this big enough? Yeah, it's big enough. All right, stat. So then it comes to here, it says edit, sort A, sort D, clear list, setup editor. All right. So I'm gonna go in, I'm gonna click edit, so I'm pushing enter. Does that make sense? thought I was pushing enter. Now I'm pushing enter. All right, I have crap stored in here. Does everybody see that? I am going to do some stuff right now that's going to mess up some things, but I'm also going to do some things that you have to know how to do. Does everybody understand? All right. So if I go and click on one of these things, let's say like this number was wrong here, and I push clear. Nothing happens. It cleared it from right here, but I have to push enter for, no, nothing happened. Sorry. If I push clear here, nothing is happening here. But if I push delete here, it goes away. Does everybody see that? All right. Now, you have these things stored in here. So this is called list 1, list 2, list 3, list 4, list 5. Does everybody see that? If you look here, L1, L2, L3, L4, L5. So second 1, second 2, second 3. Those will give you those variables. Does everybody see that? We'll see what it means in 1 second. You'll understand. Okay. So then the I got to use it. You'll see it. Okay. So then the thing is though, I just told you that if you want to remove something, you push delete, right? Yeah. If you do that at the top here, it's going to screw you up big time. Okay. So if I push delete here at the top, boom, it's gone. Boom, it's gone. Boom, it's gone. And if I keep doing this, all my list variables are gone. Does everybody see that? But I need those. And then people get confused how you put them back. Does that make sense? So what you can do is if you go to, I'm pushing second quit now. I'm going back in. I'm pushing stat. Does everybody see that? If I go down here, because they know everybody messes this up, and I push setup editor, right? Push enter. Push enter. Go back to stat. Go back to edit. Now they're back. Does everybody see that? All right. You're going to make a mistake with this. Does everybody understand what I'm saying? All right. So you need to do your homework with this stuff so that when you take the test, you're not going to make that while you take the test. Otherwise, you tell me you're not going to finish anything. You tell me my calculator doesn't work. I'm going to tell you not much I can do. Does that make sense? All right. So if I want to clear this list out, you don't push delete. You actually push clear. Now it cleared the elements in L4, but now I still have to push enter. It's gone. Does everybody see that? I'm clicking enter like 17 times, but that's just because my program is not working. All right. You only have to click it once. Does that make sense? All right. So then this clear, enter, gone. Does that make sense? All right. So just be careful with this delete and this clear thing. There's one more thing that's a major issue. This one you're definitely going to screw up. This one I always screw up and I constantly forget. Okay. So I'm typing the numbers in 2, 3, 7, 4, or that's not a 4, 4, 9, -1. Does everybody see that? Skadoosh. Error, syntax. What does that mean? Does anybody know what syntax means? Well, it means error, but if you know what the damn errors mean, it's a lot more helpful. Does that make sense? So syntax is like the way things are like written. Does that make sense? All right. So then they're saying there's something wrong with the way I wrote this crap. Does that make sense? All right. Then it's got quit and go to. Thank you, Jesus, actually, because it's got this go to thing. I push this, it's going to send me to the place where the error is occurring. Does that make sense? It's like, oh, it's over here. Even if I try and change it, it keeps giving me another error. Does that make sense? It's telling me this is an error. Does that make sense? Because this thing is subtraction. This is opposite. Does that make sense? So if I type this and push enter, it just accepts it. Does everybody see that? This is a very easy place to forget something. All right, you're gonna make this mistake. Does everybody understand what I'm saying? You gotta remember how you have to type the negatives. Okay. Question? Let's say list. No, we're gonna do it in a second. All right. So in statistics, you always got lots of numbers. Generally, there's a bunch of statistics that we end up calculating for all these types of things. I need those to describe what's going on here. Does that make sense? So if I go to stat right here, because I've given it a list now. Does that make sense? And then I go to calc, right? Calculate something. Does that make sense? Now, one var stats. What's var? Variable. One variable statistics, right? Does the set that we're talking about have to deal with one variable, right? Like heights or something. Does that make sense? Amounts of money people have. Does that make sense what I'm saying? All right. Not like your height and your weight for each person. Does that make sense? Right? One variable. Does that make sense what I'm saying? So one variable statistics. Yeah, well, that's what I got. Is that correct? I have one list, right? One variable statistics. It's like list, freak list. Does that make sense?
What is this L1, right?
That's my question. What is the frequencies is correct. No, but that's you just answered the damn question. So like the thing is here, right? So the this there needs to be some values. Is that correct? Right now, I don't have a representative value associated with each of these individual classes. Does everybody see that? I have a lot of values. Is that right? I don't know what the values are. Does that make sense? Usually, so these are values, but they're like not good enough yet. Does that make sense to calculate anything? Right? Then this is a list of frequencies. Is that correct? That's the freak list. Does that make sense? Super freaky. All right, so then this thing here, we don't have a frequency list in this case. Is that correct? Each frequency is really just one. Does that make sense? So you just delete. Ugh. Sorry, this program uses different buttons. Like the keyboard doesn't always work. So if I clear this out here, it's not letting me go anywhere. It wants me to write something. Does that make sense? So I write one. Question? Stat calc. Stat calc, one var stats. Don't forget also all the stuff on your there's videos online that you're actually asked to read on the watch on the orientation that actually go through some of this stuff also. Really? Tell me, I'll fix it. Send me an email. All right, so I'm gonna put L1 in here because that's the list that I was talking about. All I did was just click second one. Does everybody see that? Now this part here is no good, this L4. So I'm just gonna get rid of that. Does that make sense? And then I just push calculate. Does that make sense? Depends on the calculator. So then this thing here, does that make sense? Oh, what does it give you? X bar. What does that mean again? We did like barely anything last class. Practically the only thing I told you was average. Does that make sense? X bar. Is that correct? What does it mean? Oh yeah. Oh yeah. Oh yeah. What? What does it mean? Average of what? This says average also. Mu means average too, right? Read it. Sorry. Average of the sample. Does that make sense? We talked about it before. You're going to be getting your sample. You're going to be taking your average of your sample. You want this to be representative of what's overall with your population. Is that correct? But it's not always going to be, right? We need to make a distinction between these two things. Does that make sense? The parameter that we're actually interested in for the overall thing and the statistics that we calculated based off of our sample. Does that make sense? Yes. And then this one right here, this thing, mu, is the average over the entire population. They use these Greek letters for the population stuff, and then they use this regular kind of letter for the sample. Does that make sense? Bar always means average, though. Well, always. In math, nothing always means anything. But the bar usually means average, though. Does that make sense? All right, where the hell was I? Something stupid that I was saying. We were here. Yes, we were here. Whatever. I said calculate relative frequencies here. We might as well just answer this because it's kind of simple. Oh, I said I was going to do it on something else. I said I was going to do it on the calculator, right? So maybe we should do that. So let's type in some numbers here. All right, so I'm going to go back to my editor. Edit. Come on, bro. All right, so then this, clear, enter, it's gone. Does everybody see that? All right, I'm gonna type in, I'm just gonna type in all the numbers because I want to show you how to calculate something using those lists. You were asking about the list. Okay, so then this 0, enter, 61. I'm just literally typing exactly what it says here. I don't necessarily recommend typing all these numbers in like I'm doing. I'm just trying to teach you. Like when you're actually doing your homework. Some of them you don't really have to type in. I'll explain after we do the question, okay? So this stuff is here, right? Then we have frequencies, 5, 10, 8, 6, and 2. Is that correct? All right. He says he wants us to calculate relative frequencies. How do we do that again? Okay. So what is that? What's the sample size then? 100? Where do you get 100? 10? Where do you get 10? I mean, I got 10. This is like 31 sounds better. 13, 19, 21, 31 is correct. All right, it says frequencies right here. Is that correct? These are the things that are organized in our sample. You add this up, you're going to get the sample size, right? Right? Okay. So then this, I just want to write it in terms of some of the notation that they have. Notation just means how they write stuff. The more you understand how they write stuff, the more you would be able to read it and answer your own question. So then this, and some of the questions in the stuff starts asking us to use these notations. So this, if I say sum, this thing means sum. Does that make sense? Like if you were gonna say like the sum of a bunch of numbers, I bet you would write this. Like if you had to do it a lot, you'd write like S, and then you write like 5, 10, 12 or something. And that means like add those up. Does that make sense? Well, guess what? Greek people didn't have an S or don't have an S. They have a sigma. This is called capital sigma. Does that make sense? Oh, guess what? You think it's coincidental that their thing starts with an S and our thing starts with an S? No, like English, like they use these things in a lot of languages, honestly. Does that make sense? So the sigma, then you have to start. So like if I start adding something up, another problem is like in these books, if you wrote a statistics book and I started writing out all the things that I was adding up, it would just be pages and pages and pages of things that I'm adding up. It'd be useless. Does that make sense? So you need like a shorthand notation. Start being able to write what to add up. Does that make sense? So for instance, if I was like, oh, add up the amount of money everybody has in the first 3 rows. Does that make sense? I would start with person 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, let's say. Does that make sense? Go from person 1 to person 11, add up how much money they have. Does that make sense? The way you write that is you write start with 1, end with 11. Does that make sense? And then add up the amount of money. And then the I changes. So this would be the money from the first person plus the money from the second person plus the money from the third person plus the money from the 11th person. Does that make sense? But instead of writing all that out, I can just write this. Does that make sense? So this is referred to on the bottom here. Like it'll say like, let's say I equals something. This is the lower starting point. And this is sort of like the ending point. And this part here is what's being added. Does that make sense? Start with 1, go to 11. What do you mean? So like if I change this and you start telling me that this is like, I don't know, 27 and this is 137, then this is going to start at 27. And then we're going to end up adding up until we get to the 137th person. Does that make sense? The only problem is like, I don't want to write all this shit out. The middle? This thing? Well, what I'm trying to say is like, we don't write this. That's just to explain what that thing means. Does that make sense what I'm saying? Then they just start writing this instead. And I'm trying to say to you that if they write that, I don't want you to think it's like some complete craziness. Does that make sense? So if I write sum from I equals 1 to 5 of fi, right? Then this means start with, make this thing, this I thing is sometimes called the index of summation. Does that make sense? So it's like, it sort of changes to say what you're talking about. Does that make sense? So then this means F1 plus F2 plus F3 plus F4 plus F5. But we know that if there was like a lot of them, like I don't want to write that out. Does that make sense? Like if it was like 1,000 or something, right? I would just be like, we add it up. You know what I'm doing, right? Start from 1, go to 1,000. Does that make sense? Or tell the computer to do it, right? And guess what? That's this type of thing, like the information associated with these things is the same way you type in the computer, all right? So then this, so you add this stuff up. That means this was, what did you say? 31, right? Is that correct? Okay. So then how would you calculate the relative frequency for the first class? It would be 5 divided by 31, right? Right? Then this would be 10 divided by 31. Then 8 divided by 31. 6 divided by 31. 2 divided by 31. Is that right? Does that make sense? Now this has to add up to 31 divided by 31, or I missed something. Is that correct? Any questions so far? Now, sometimes people will start complaining and they'll be like, that's not a relative frequency because you didn't write it as a percentage. Does that make sense? Does that make sense? How would we write it as a percentage again? I'm going to use my calculator. How though? 5 divided by 31. Does that make sense? 5 divided by 31 is going to give me a decimal. Is that right? And then just move it over 2 decimal places. Does that make sense? You got me? All right, but it's going to be even easier than that. They're going to use, well, so the math lab is generally going to tell you the way it wants the answer. Okay. Relative frequency is generally a percentage. I've seen it written every way though. I've seen it written as a decimal. I've seen it written as a fraction. You know what I mean? Honestly, if someone really gets hung up about this, they're kind of stupid. Like people, I understand making a definition in class and then saying follow that every single time, and that there is a point to doing that. But this particular thing, I think it's more important that you understand fraction, decimal, percentage, and how they're all the same. Does that make sense? Now, the thing is there are some questions where they're going to ask you to do things with a fraction. There are some questions where there's a lot of questions where they're going to ask you to do things with percentage. There are some questions where they're going to ask you to do things with decimal. So they're just going to randomly ask. Does that make sense? All right, but watch how simple this is on the calculator, okay? And this is the same thing I was talking about with the first class with the Excel stuff, if you remember that story. All right, so this thing here, right? What do I have to do to calculate the frequencies? I have to do 5 divided by what? And then 10 divided by what? So really, it's all this crap divided by 31. Is that right? All right. So instead, could I do them one by one? Sure, it's a calculator, right? I could go here. It even says equals right there, right? Just start typing in here, 3 times 7 times whatever, it'll calculate it for me. Does that make sense? So I could do 5 divided by 31 right there. Does that make sense? But if I'm going to do divide by 31 for all of these things, the whole point of having a spreadsheet is you don't have to do each one separately. Does that make sense? All right. So then if you go up here to this L4, right? So on the bottom here, you're typing in elements in the individual list. Up here, you're doing something to the entire list. Does that make sense? Now it's all of a sudden saying L4 equals the whole damn list, right? So I push enter. Now it takes me here, the cursor's here, right? L4. Well, I really just want L4 to be L3 divided by, right? Divided by 31. Is that correct? But then that's going to be a decimal, right? So then they want it to be a fraction a percentage, right? I can make it move the decimal 2 places right now. Just multiply by 100. Does that make sense? Boom. Answers. That's what I want you to do. Does everybody understand what I'm saying? I need you to understand the formula. Yes. Otherwise, you can't answer the question. Otherwise, you're not going to remember. But I want you to learn how to use the machine. Does everybody understand what I'm saying? Because the point is to, sorry? What do these look like to you? Percentage. 19 point something? 19.355%. Does that make sense what I'm saying? But if I was doing, okay, so wait a sec. 5 divided by 31, right? That's not bigger than 1, right? What do you mean most likely? How many times 31 going to 5? No, but not most likely. Definitely not. 5 goes in, like 5 divided by 31, right? 31 does not go into 5, right? It's got to be less than 1. Is that correct? So this fraction right here, 5 out of 31, if you were to convert it to a decimal, has to be less than 1. Does that make sense? But we have numbers here that are definitely larger than 1. They're percentages. Does that make sense? All right. All right, I'm just gonna do this one, and then we'll finish. Kevin asked some of his friends how many hours of work, whatever this thing is, job results. Construct a frequency distribution, use 4 classes, class width of 2 hours. We're not doing this. You have to figure that out. Lower limit, we're not doing this. You have to figure that out also. I'm not gonna give you that information when you take the test. So use 4 classes, it says. All right, I'm also gonna change, what's the biggest number here? What's the smallest number? I'm gonna change the 3 to a 2, okay? All right. So now the minimum is 2. Does everyone understand? All right. First step with this, always round up the maximum. Round it up to where? Everybody always asks. I don't care. Doesn't make any difference. You just have to round it up at least 1. Does that make sense? I think it would make most sense in this case to round this to 10. Does everybody see that? All right. So I'm calling maximum star 10. Does that make sense? The formula I said previously was that, so the next thing is calculate class width. That I said was max star minus min, all divided by number of classes. Is that correct? Now, generally, the number of classes when you do these things is somewhere supposed to be between 5 and 12. Of course, the book picked 4 here, but whatever. All right. They told us to do 4. We're going to use 4. Does that make sense? You don't want too few classes because then there's like lots of crap in all those classes and I can't see the difference. Does that make sense? You don't want too many classes. Then there's going to be a bunch of classes with like nothing in it. And like, what was the point? Does that make sense? So they start saying 5 to 12. Okay. There are formulas to calculate these things. We don't talk about it in this class though. if anybody actually wanted to know, I could show you, but you don't have to worry about it. All right, so this is 10 minus the minimum 2. Does everybody see that? So then we get 8/4 or 2. The class width is 2. Does everybody see that? Does that make sense? Label LCLs and UCLs. What was LCL and UCL again? Do you remember what those mean? Lower class limit, upper class limit. Does that make sense? What would the lower class limit have to be? The lowest one. 2. Because we have to include all the numbers, right? So whatever the minimum is the lowest one. Does that make sense? So we just take the minimum, stuff it over here, 2 to something. Is that right? How do we use the class width to construct more of these things? Say one time. That's correct. So then this would have to be 4, right? We said the distance between the two classes is the class width. Is that right? Does that make sense? Added 2. So then here we get 4. Then we would get, I guess they told us to do what, 4 classes. So then like 6, 8. Is that right? All right. How do I determine the maximum thing? What goes here? Say again? 10? No. Can't be 10 because if you put 10 here, then the problem is like this stuff would be like overlapping. Does that make sense? 1, no. 3, why 3? Because that's like the thing that's missing. Is that right? So like this, like it can't be 4, right? Because then they're forward going both of them. Does that make sense? I want to make it like 3.9, but like there is no decimals here anyway. Is that correct? Does everybody see that? Or these things are referred to as discrete. So then we put 3 here. Does everybody see that? So what's the next one going to be then? 5, because you add the class width again. Or you just look at this, it would have to be 5. Is that right? But I like using the class width. Does that make sense? 5, 7, 9. Is that right? Does that make sense? All right, now I'm just gonna say what would have happened. What, because everybody always asks, why the heck did we just round this up, right? And I think that's a good question. Okay, so the if I didn't round, if you don't round up, right? And I just did max minus min. Seven over 4 is 1.75. Does that make sense? All right. First class need to start at 2, right? 2 plus 1.75 is 3.75. Add 1.75 to that is 4 is 5.5. Add 1.75 to that is 6 is 7.25. Does that make sense? Does that make sense? What would this go up to here? Well, I guess I don't know. 3.74, 5.4. Wait, 3.74? 1.77. Is that right? Did I add wrong? .49. Yeah, that was right. Good. All right, 5.49, right? 7.24. Does that make sense? What would the last one be then? You got to add 1.75 to this. Does that make sense? So then it's only going to be what? 8.99. Is that correct? Why is that a problem? There's a 9 here. Does everybody see that? I wouldn't have anywhere to put it. Is that correct? Does that make sense what I'm saying? So you do this little rounding thing so that this is going to include the largest value. Does that make sense? Otherwise, where does 9 go? Uh-oh. Does that make sense? All right, so then this, now we got the 9 there. It worked out perfect. Is that right? All right, I'm gonna finish this right now. I'm sorry. So then this 2 to 3. We got to count how many numbers are between 2 and 3 here. Great. We only have 1, I believe. Please help me here because I'm gonna miss numbers. All right. So the 4 to 5. So this is 1. Wait, 1, 2. That's it, right? 6 to 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Hopefully I didn't miss anything. Does that make sense? Hopefully I counted right also. 8 to 9. 1, 2, 3, 4, 5, 6, 7, 8, right? We should check this to make sure we counted correctly. Okay, so 8 plus 2 is 10, plus 14 is 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 24. Does everybody see that? Does that make sense? Yeah, I mean, it's not perfect checking, but you know, if I miss one, I'll be able to tell. Does that make sense? So then you have this. Does that make sense, guys? All right, now they want you to know what a histogram is also. But a histogram is just a bar graph. But I got in trouble in school because I said it was just a bar graph. They're like, no, it's not just a bar graph. The bars need to touch. Still a freaking bar graph to me. All right, but so like if you have 2 here, 4 there, 6 there, 8 here, and then 10 there. Does that make sense? Then I'm going to construct a bar with height 1. Well, yeah, whatever. I'm going to construct a bar here with height 1 there. Does that make sense? 4 to 5, I'm going to construct a bar with height 2. 6 to 7 is 13. 8 to 9 is 8. Does that make sense? So this is referred to as a frequency histogram. Does that make sense? A relative frequency histogram means you're just plotting relative frequencies, but they have the exact same shape. All right. Question with this? Why would you want to do this? Because this is terrible. Having a bunch of data like this is useless to anybody. This is a little better. Organizing it this way. Does everybody see that? This is even better. So I just look at the stupid picture. Does that make sense? So anybody that tells you that they don't like graphs, I don't think they know what it means. Does that make sense? I would much rather look at the stupid picture than these numbers. Okay? Any question? All right, make sure you guys look at your homework.